All right, we're going to continue on with our random rectangle activity. In this one, we're going to conduct a simple random sample and a stratified random sample. So how do we determine the average number of rectangles per figure? Well, we could conduct a census, which I did, and that's how I got 7.9. I added up all the squares and it ended up being 791 divided by 100 and 7.9. All right. However, I'm guessing many of you refused to do the assignment. I'm guessing that among those that did the assignment, we'd still have some varying answers because census are notably have errors. So instead of conducting a census or just using our best guess or judgment, let's utilize some sampling techniques that employ randomness. First, we're going to use, by the way, we're going to use samples of size 5, which are really too small, but we don't want to spend a whole lot of time counting squares, and it takes a little bit of time to do this. So first off, we're going to conduct a simple random sample. This is the basis for all statistical sampling. So basically, this is the starting point. This is the gold standard. This is what you start with, all right? And the difference from the convenience sample and a census in that randomness is utilized. In a simple random sample, all subjects have an equal chance of being selected. Actually, that should be true for all types of samples that involve randomness. So that right here, this bracket right here, is typical of all random samples. However, this next part, and every possible combination of subjects has an equal chance of being selected. This is only true. This is only true for the simple random sample. So the underlying part is only true for the simple random sample. And the reason being is randomness is involved every single time we draw. Everyone's in a hat. We have a single pool. We're only going to draw from the single pool, and everyone is in that pool. So every single possible combination has an equal chance of being selected. All right. So that's so important. I'm saying it again. In a simple random sample, all subjects have an equal chance of being selected, and every combination of subjects has an equal chance of being selected. That separates a simple random sample from everything. All the other types of samples that we will conduct. So how do we conduct a simple random sample? Typically, a number is assigned to all subjects in the population, and then a sample of numbers is randomly selected. Acceptable methods of selecting a number using a random number generator, numbers in a hat, random number tables. We use random number tables when we ran simulations. We're going to use a random number generator on a calculator here in a moment, or we could write down all the numbers in a hat and draw. If a random number table is used, it's necessary to describe the selection process and providing the stopping point and define how duplicate values are to be addressed. Unfortunately, it's often difficult to obtain a list of the entire population, and there's a chance that our sample will not be representative of the population. However, even if it's not representative, it's not biased because of our method. Our method was not biased. So I'm going to use the random number generator on my calculator. To do that, I'm going to press the math button, arrow over to probability, and then I'm going to arrow down to number 8, which is random integer with no repeats. I have my lowest number was 1, my highest number is 100, and I'm going to select 5. And when I did that, I ended up getting figure number 15, figure number 95, 84, 53, and 10. And I had no idea what would happen. I might have gotten a sample that wasn't too good, but I ended up getting one reasonably good. So when I look at sample number 15, it had 16 squares. When I look at sample number 95, excuse me, sample number 95, apparently I did not circle that one. 2, 3, that's not good. Sample number 5, 95, which I should have circled. That one had 12. All right. Number 84 had 2. Number 53 had 3. and number 10 had 4 right here. When I added those up, I ended up with 37, and 37 divided by 5 was 7.4. So I ended up with a little bit better estimate than I had before. All right. So that takes care of that one. So that was a simple random sample. And so it's definitely quicker, or definitely easier, or better. I shouldn't say easier. It's definitely better than what I had before. Because remember, this is the actual population, 7.9. And with a simple random sample, I was reasonably close. I was 7.4. I was still a little bit off, but not too horribly. And I used randomness to select each and every single figure. All right. On a systematic random sample, randomness involves randomness, and every individual has an equal opportunity being selected before I start. Before I start, each one has an equal opportunity because I randomly select the very first number. All right. And in this case, every group is not possible. Every group is only possible with a simple random sample. So to perform a systematic sample, we divide the population by your desired sample size. Well, our population was 100, and I divide it by 5, and I get 20. All right. And we'll randomly select the first number from 1 to 20, and then we'll select every nth value. In this case, we'll select every 20th value. All right. Systematic samples are very fast to operate and very useful if we're having people entering the building, or we're working with a stadium. So when I did this, I went to math, arrowed over to probability, drop down to random integer, no repeats, press enter. 1 was my lowest value, 20 is my highest value, and I only want one value. All right, and I press enter, and in my case, I got 16. So the first one I'm going to choose is 16. I'll add 20 and get 36. I'll add 20 to that, and the next one will be 56, and then 76, and then 96. Well, when I did that, 16 only had 4. The 12th one had 36. The 10th one, or number 56, had 10. The 76th one had 6. And the 96th one also had 10. And I added those up, and I got 42, which I divided by 5 and is 8.4. Once again, the actual mean was 7.9. So I'm a little bit above here. I'm 0.5 above here. I'm 0.5 below. So both of these were reasonably close, which was much better than what I came up with before when I did my judgment sample. And I said, oh, 12. And then I came up with 11.6. All right. So simple random sample. What you need to remember, every individual has an equal chance of being selected, and every possible group has an equal chance of being selected. Systematic. We randomly select the first one. Every individual has an equal chance of being selected at the beginning, but not every group. All right. Both are very effective. Systematic, extremely fast. Simple random, a little more difficult to conduct. All right. Because in a simple random, we have to number everybody, whereas a systematic, we're just counting them as they come in. All right. I hope you enjoyed this. I look forward to seeing you on the next one. Thank you.